director with Altman Landry & Company. We're a strategy consulting firm focused on communications and media. And the topic of this panel is on mobile delivery of video specifically, but in general focusing on the mobile delivery and how that might be different from fixed traditional delivery to PCs or TV for that matter. So before we get started on the panel topics, I just wanted to quickly introduce each of our panelists. So going from left to right here, we have Joe Ambray from Verizon, Director of Product Development and Management of Video Services. We have Josh Gagliani, CTO of Highwinds. Kumar Gopalakrishnan, close enough, sorry. Director of Product Management for OpenWave Systems, and Michael Widener, CEO of Blaze. So what I'd like to do is just spend a few minutes setting some context for the panel topic, and then we'll go into a series of questions and then wrap it up with Q&A. So when I think about mobile CDN and trying to compare that to the fixed CDN world and the delivery of content over mobile networks, a couple of interesting demand-side trends that I think about are the rapid growth in mobile data traffic. If you're at the keynote, you heard 39-fold increase in mobile data traffic. But on top of that, you have a proliferation of devices across not only different types of mobile phones, but also tablets, other types of devices. You have a consolidation of operating systems, and also a wide variety of different networks, including the emerging 4G and greater Wi-Fi offloading. So in that context, I think the first question to start off for our panelists is, what are technologies that are being deployed to facilitate mobile video delivery, and how is that any different? How is that any different from a fixed network? So Joe, do you want to kick that off?
Yeah, sure. I think a lot of the focus really in the last few years has been on the devices themselves. Some of the things that if you come out of a fixed device realm for multimedia that you took for granted there, as far back as the mid-90s, have only come into existence in the last couple years on mobile devices. Just very simple things like being able to keep audio and video synced. The APIs didn't exist to even do that because no one was watching 10, 20 minutes of video. Progressively, you've been working back from the device to get more efficiencies, but I would probably say last year was the first year that mobile video worked as opposed to just worked.
Great.
Yeah, I think I just want to point out that getting ready for this transition is, in every sense of the words, not optional. That we're seeing just staggering cutover in terms of the amount of traffic that's going to these devices. And mobile's getting to be sort of a tricky word, where we see, let's say, 3% of our traffic, 3% of our traffic going to mobile devices 60 days ago and 8% now, right, on a fractional basis. So that tells you there's just a sea change in how much is going there. It's still true that probably 3/4 of that is going to mobile devices that are on Wi-Fi. So it's it's only the mobile experience as compared with the mobile Wi-Fi experience. Those are two separate things and result in different uptake. But regardless, we see both of them just growing colossally. So it's something that absolutely everyone in the room has to be thinking about.
While we're looking at the new devices available for mobile video and so on, one thing to keep in mind is the differences between a fixed and a wireless network. On the fixed network, let's take the case of a typical, cable-based fixed network. You're looking at about 100 Mbps of capacity available over DOCSIS 3.0 to about 500 subscribers. Simultaneously, say 6 months from now, you're looking at a LTE network where you have about several thousand, a few thousand subscribers tied to a tower which has about 75 Mbps or so in capacity. So if you look at the average capacity available per subscriber going from a fixed to a wireless network, there's an order of magnitude difference, which makes the challenge an order of magnitude more complex, right? So that's one. And then in terms of user experience, you look at on fixed networks, it's all about providing the best fidelity experience and providing more of entertainment experiences where video really shines, whereas on mobile, as much as people are starting to do more of Netflix on tablets and smartphones, largely video is about communication. The immediacy of delivery is of far higher value than the greatest, most immersive experience on mobile. And that changes the needs on the network on what type of solutions are needed and such. And finally, also regulatory environment. Across the world, there's a wide range on what's expected of mobile networks, but then even within the US, if you look at the FCC requirements, the latest requirements, they're more relaxed when it comes to wireless networks, giving mobile network operators and any solution provider in the ecosystem more options to work with in offering solutions for mobile video delivery.
I can talk a little bit about the content end of things. Yeah, so we've done a lot of research into looking at what companies are doing on optimizing for mobile devices for their website content. And if you look at the top 20, 50 sites on the internet, all of them have a mobile version of the site. Some of them even have an iPad version of the site, and they're customizing for different platforms. But we analyzed the Fortune 1000 enterprises, and only about 175 of them, or 17.5%, have mobile sites today. So there's still a lot of work to do in just creating basic customized mobile websites out there, and let alone looking at video and other more sophisticated technologies.
So Josh, you help operate a CDN. So how can a CDN help some of these companies that haven't really developed a good mobile presence to deliver their content to mobile devices? And what do they need to worry about that makes mobile devices different than the fixed devices?
Well, the biggest difference is simply the proliferation of devices, which means the number of additional targets that are required for video. So what we see very predominantly in terms of traffic, but also just on a request basis, is that let's say on a request basis, a quarter of the traffic that's going to these devices are MP4 files, and and that's true whether we're looking at iPhone or iPad or on Android. So that said, again, whether these devices are mobile or whether they are Wi-Fi, you're going to need at least two renditions there. And then if you make a chart of the most popular devices that your subscribers are on, and let's say sort it by most prevalent, so you're going to see depending on when you look, you're going to see iPhone and Android tied. Capabilities are very different because a lot of the Android phones are simpler phones, but they have very high-end tablets as well. And then you go out into all the various BlackBerry Smart and Samsung smartphones. Let's say you look at the top 40 devices. You might be looking at 25 different versions of the stream if you wanted to provide the best quality possible to each of those devices. But you can probably get it down to 8 or 10 renditions, targeting something that's pretty good on all the devices and adapting between them. And so the key thing is to be prepared to stream with a CDN that can support support multiple renditions and generally make this experience as painless as possible in terms of adapting the content.
Mm-hmm. And Kumar, as we think about not only different devices, but you brought up the Wi-Fi offloading. How does that impact how a CDN would want to try to deploy their architecture in a mobile environment?
So we talk about mobile video and the definition of that has evolved quite a bit in the last, say, 5 years. It used to be video delivered to 1-inch screens on feature phones. Then it's become slightly better quality video delivered to 3-inch screens on smartphones. And the next couple of years, it's going to be largely about video delivered into 7, 10-inch tablet screens, right? But at the same time, if you look at it, about 85% of the iPads being sold today are Wi-Fi only. They are not equipped to pull traffic over 3G or 4G. So effectively that means a lot of what we call mobile video is mobile device specific, but not necessarily mobile network oriented. It's going over traditional Wi-Fi through your home or office ISP. And that changes the dynamics on what's involved to offer a mobile video solution. It's not just about providing services that operate through the mobile network, but also potentially for solutions for traffic that is pulled through a Wi-Fi network at home or in an office environment. And Wi-Fi offload is one way offload is being done, but there's also other solutions. For instance, femtocells offer a way to offload traffic through broadband, but at the same time managed by the carriers. There's also managed Wi-Fi being experimented with. And then there's also upcoming techniques for offloading at the base station for LTE advanced type networks that are being explored. So a solution that looks into providing a comprehensive mobile video delivery optimization has to look into these other options as well. How do you not only optimize traffic going through the mobile network, 3G, 4G network, but also potentially offloading it to cheaper alternatives, whether Wi-Fi, femtocell, or at a base station.
Mm-hmm. And Joe, at Verizon, how do you guys try to think about optimizing delivery across all the different devices that Josh was talking about and the different Wi-Fi versus 3G, 4G?
I think the sad part is it's not only the fidelity you have to deal with, but the matrix gets even uglier when you now overlay DRM on top of it. And it starts to break poor Excel spreadsheets trying to keep track of all of these different axes and different devices. And you can even come upon devices where you have multiple DRMs to potentially have to field. So really the problem, as we've been working on sort of chipping away at it, has been less about the CDN and more about the systems on each side of the CDN. So being able to take in content and not only get that content in, but get it into the right recipe by specific devices. I mean, we've seen devices where we have to oversaturate video so it actually looks good on that particular device, but that same profile would look like garbage on another device. And so we see a huge proliferation of these recipes. Just when we think we got it down to 10 or 5, we find the next 6 in the upcoming devices that are headed your way. I mean, the tablets have exacerbated that even more because they're not even close. They're 16 by 9s and 4 by 3s and 7 by 10. I'm sorry, 7 inches and 10 inches. So primarily what we've done is moved our focus more to the 3-inch and above. We don't see very good consumer engagement, at least that makes it worthwhile on the smaller screens. I can remember VCast videos on the 1-inch screen, which was quite the pleasure at 96K and 15 frames a second, barely video, something like a flipbook you did in elementary school, to where we come now at 2997 frames a second and trying to hit things like a meg, 2 meg worth of fidelity. And so right now we're dealing with almost it seems like an endless set of SKUs that have to come in. So the content management system that's dealing with these mezzanine files coming in and being able to get it through is, at least in our experience, been the bigger challenge. And then all the application integration on the device with, as long as you can really get the economics of the CDN, and the CDN can deal with Flash video here and Windows Media over there and some flavor of MPEG-4 and 3 more flavors of MPEG-4, that usually is less of a challenge than this. I got one mezzanine file and I want to get it to all of these places and get it to there in a timely fashion, because when the device has been out for 4 or 5 weeks, if you're not on that device, 6, 7 weeks, you've already eaten into 10, 20% of the device's life cycle. So it's really that recipe and being there when it launches is probably the biggest challenges, the dragons we're trying to slay.
That's a good point. So we have complications around the devices, complications around the in-networks, and complications also with the ingestion and distribution and DRM systems. So what can you do that's different in a mobile environment to help solve some of these complications? Do you want to talk a little bit about what you're trying to do to help address those?
I mean, primarily our focus, even though we've launched a bunch of high-resolution experiences on 3G, those were really in preparation for a transition to 4G and much more prolific availability of Wi-Fi as you move about. Finally, in Manhattan, you can actually go most places and find an open Wi-Fi network somewhere. And so anything you see sort of in 3G is really just giving consumers a chance to play with it. But a movie over 3G takes over an hour to download on a 4G connection. Certainly this will slow down a little as the network gets more utilized, like 10, 12 minutes of download time and a superior experience when it actually makes it to the device. So really much more looking to the future. Our earliest investments in mobile video go back to 2005, and that was a lot about getting to this day when you had devices that were more appropriate and the networks that were better equipped to deliver an experience consumers would like. The number one objection on mobile video is it looks like garbage. And that's the biggest barrier to entry. You can get a lot of people to try it, but if you look at a lot of the stats, getting them to come back after that first experience has really been the big challenge. So drilling into why didn't they come back, eliminating those pieces has been the, sort of the core focus.
Got it. And Josh, how are you guys dealing with all these challenges that we've raised?
For the most part, it's a focus on keeping people from losing their minds when tracking 20 versions of something. Making it easier to ingest and switch between multiple streams, and ultimately to be able to analyze multiple streams both separately and as if they were one. One of the things we're really interested in is providing actual feedback. And perhaps not just on a your content basis. One of the things that's really frustrating is, okay, I just heard 37 numbers and a whole bunch of scary stuff about format explosion. Now I've got an event and I want to stream it, and what 5 formats should I pick, or 10? And so being able to provide people with real feedback on what a good take rate is, what they should expect to see, and any information we can give them about who their audience is. It sounds silly, but many of the things, many of the solutions in this area are actually non-technical. That you just have to remind people to think about things and think about the fact that an event during the day is going to be watched primarily on Wi-Fi, and and something that people are watching, let's say primarily VOD, or that happens in the evening. There's going to be this transition period where it's mobile, and then it's going to be wireline from residential carriers versus maybe during the day from enterprise carriers, and really, rather than thinking about it as an abstract series of technical specifications, to think about, wait, who are my users and what are they actually going to do? Again, it's not a product feature, it's not a technical answer, but it's absolutely critical to success.
Kumar, how are you guys helping to address these problems?
In terms of solutions, right? The CDN is a good way to deliver the traffic, but in terms of what is truly needed, there's 2 aspects to the solution. One is being able to manage congestion in the network, which is limited by the capacity of the network, and the other aspect is in reducing transit costs. Reducing transit costs pretty much invariably boils down to using caching, which provides a lossless mechanism for reducing transit costs. And then when you look into congestion management, there's 2 aspects to it. One, where you do have adaptive streaming deployed, it's naturally an end-to-end congestion-aware technology, and it can provide the simplest solution for addressing congestion. And then in cases where you do not have adaptive streaming deployed, that, for instance, the biggest video content provider online today is YouTube, and it does not use adaptive streaming. There are various reasons for that. And how do you manage that progressive download delivered HTTP traffic? That's the challenge. And for addressing progressive download HTTP traffic, there are a few tools possible. One could be, say, real-time transcoding of content. It's very expensive, but it is an option, though. Where you pull content from YouTube and in real time decode it and re-encode it to a lower bit rate based on available capacity further down towards the edge of the network. There is another option where, for instance, you keep track of how much of a video is being watched, because typically when video is pulled from YouTube, the client may pull down the entire content for the entire duration of the video, irrespective of whether a user is actually watching the video all the way through to the end. So it pays to actually throttle the traffic so the download rate matches the playback rate. That would be one tool. And finally, when you look at adaptive streaming is congestion aware end-to-end, but it's more in the interest of you would say the viewer and the content provider, and it operates at a single session level, and it's not quite aware of the overall situation in the network. What's the aggregate behavior of the network? That's not something you can do between the client and server. So offering a mechanism to police the adaptive streaming traffic is another possibility as well that a network or a content distribution network could employ.
Got it. And Mike, you're helping a lot of these content providers see how their mobile websites are working. How are these technologies that those three panelists have talked about working? How is the experience?
Sure. Today? Yeah. I mean, our business is more about content, web content, than video per se. We provide services, a real-time service to transcode the content of the site and optimize it, the presentation layer for various browsers. And so we've done a lot of research to look at how does a desktop browser perform differently than a mobile browser. And it turns out that many of the optimizations that you might apply to make your website faster also apply to mobile. But there are unique nuances to them. For example, domain sharding is a method of splitting your content across multiple domains to improve the speed at which it would load in the browser. Well, it turns out in a desktop browser, the right answer is spread your content across 5 domains. In a mobile context, 2 is the answer. And if you have 3, then it's going to make it slower. So the challenge for content owners is really looking at how do I build a site that's going to optimize performance on all these different devices that are proliferating like crazy. And there's kind of 2 schools of thought out there. One is to create a sort of mobile version that redirects people to the mobile site. The other idea is something called responsive design, where you create a site that is not a mobile site per se or a desktop site per se, but one that dynamically adapts to who's asking for it. So for example, if I'm in my browser and I resize my window down to 300 pixels wide, the site layout and design optimizes itself, and the images optimizes itself for that viewpoint. If I'm coming on a mobile device, then obviously that's what I would be viewing with. So I think that the challenge is that we're going to continue to see a more heterogeneous versus less heterogeneous world going forward, and that creating designs and performance optimization techniques that don't necessarily design for an iPad or an iPhone, but designs for a broader spectrum of devices is going to be the way to go to provide for a more flexible and less painful solution.
Got it. Well, I want to go back to one thing that Kumar was mentioning, which is, obviously mobile CDN, just like any kind of standard CDN, is trying to reduce congestion, and one obvious technique for that is caching. And in the traditional CDN world, largely to date, it's been around distributing servers as far as possible or as close to the edge as possible, and oftentimes those are established in data centers or other types of interconnection points. So if we think about a mobile world, infrastructure-wise, where is that caching software? Where is the caching servers going to be, and is it going to be any different than the traditional world? Are they going to be at the cell site? Are they going to be at the mobile switching center? Are they going to be somewhere completely different? Would love your perspectives on that. So let's just start from Mike and come on down the road.
Right. Well, I mean, I think that traditional CDN services can continue to be useful in a mobile context. Our business is about transcoding of content and optimizing the content itself. And we sell primarily to the site owners who optimize their own content, whereas other vendors like OpenWave do some of this stuff, but in the carriers themselves. And so there's going to be different approaches to this, ones that look at integrating optimization services into the CDN and into the cloud that are provided directly to content providers, and then other business models which are build some of these optimizations and mobile performance improvements into the carriers and provide that as a differentiator as from one carrier to another.
If you look at the 3G network topology today, for instance, for a tier 1 US carrier, typically you have about 5 to 10 regional data centers, which is where the mobile network connects to the internet backbone. So if I, for instance, do a speedtest.net on my iPhone, sitting in the Bay Area, it shows I'm going to the internet through Seattle, right? because that's the closest regional data center where AT&T connects to the backbone. That is 3G today. But as LTE is rolled out with the true 4G model with metro Ethernet rings and such, it's likely that if I do a speed test on that, it's going to show I'm connecting from the Bay Area because there is a local metro level connect back to the backbone. So as the transition happens from the regional data center based 3G architectures to the metro ring based 4G architectures, the location of CDNs for mobile networks is going to be moving away from being close to the regional connect points to being the metro connect points. And if you look at where the traditional CDNs are today for fixed networks, they have a point of presence in all the metro regions because that's the way the fixed network is designed. And the 4G architecture for wireless is pretty much identical to the fixed network. So in that sense, even if the traditional CDNs do not do anything special, they're ready for 4G, right? And in addition to that is the other conversation we had all this morning about building in-network CDNs. A lot of the action there today is on the fixed network side. But say, for instance, a carrier that has both fixed network and wireless network puts in CDN servers, which are either slaves to outside the traditional CDNs acting in a federated mode, or they could be offered as CDN utility services by the operator themselves. Those in-network CDNs could eventually, in the same sense of being the 4G wireless architecture mirroring the fixed network architecture, become available to 4G wireless devices as well. So I think overall CDN architectures, whether it be the traditional CDNs or the new upcoming in-network CDNs, they're on course to becoming 4G ready. They are 4G ready pretty much. It's just a network that's moving from a 3G to a 4G architecture.
Yeah, I think if you, more simply, if we, the more we go towards a world where all of the networks are small and highly interconnected with networks that are physically close by, but may not be from the same company. So as the networks get smaller and there's more and more peering, you spend more on network gear. You spend more on network gear. You have more things to capacity plan. But on the whole, you get a faster user experience and less requirement for server caching because you can get close to some mega data center that has the content you're looking for. And as networks, and let's say eyeball networks or mobile carriers adopt a walled garden strategy and put more and more distance between the other pieces of the internet and their eyeballs. Then that carries with it, although in some senses you feel like you have control over your network and you may reduce some internal costs. In order to provide the performance for your users, you end up having to put gear back inside in the form of either transparent caching or some sort of CDN federation or just other transparent proxy work. So really, we kind of live in this continuum, and the networks are sloshing back and forth in terms of architecture. But really, it's not so much a consistent change in one direction as where the servers go that host your content and what your interop agreements are is largely determined by kind of the overall feel of your network, whether it's multi-connected and of small pieces or extremely top-down hierarchical like the internet of the late 90s.
I hate when I'm on a panel and I have to agree with the people before me. That makes it no fun. Yeah, I feel a little dirty saying this. To mirror what was already said, I think CDN, the notion of it being this sort of separate from the rest of the network is not going to be that different than how VPN, if you remember from the late 90s, it was very sort of dedicated and standalone and maybe even hired a company who provided VPN so you could get into your office. I think we're seeing more and more of that blending of the caching into network elements down to edge routers and other pieces, and I think I like the term, I'll have to borrow that, the transparent caching. So a much more blending of the experience. But if we just look at the next couple of years and sort of where these caches are going to live today, where maybe you have a half a dozen or a dozen cache sites, the proliferation of even that same kind of definition coming up at least one order of magnitude, but then getting augmented further down the network, really primarily the network operator trying to keep these networks alive. I mean, not to if you just take fixed video viewing in tiny little Fios TV with almost 4 million customers, we're slightly under 1 billion hours of video viewing in even a month. To even have a fraction of that come off and move on to some of these other network architectures is going to absolutely require a lot of work through all of the elements. So just like a catalyst switch that you bought many years ago, you had to plug this VPN appliance to it. Now it's just like you check the box when you're ordering from Cisco, please give me VPN. My expectation is the Huaweis and the Ciscos of the world and the Alcatel-Lucents will better bring these type of capabilities right into the network, just like VPN now is just a little checkbox on your equipment.
Great. Well, I wanted to turn it over to questions from the audience. Any questions?
Wow, we did that good of a job.
They're
Wow.
asleep.
Yeah?
I'm curious how you guys have dealt with the issue of sort of the mobile network being not guaranteed. The network bandwidth is not available, or local power saturation, and the use of either adaptive streaming technologies or sticking with progressive download for consistency of playback.
Sticking with progressive download for consistency of playback. Adaptive streaming is neat, but to get that very high fidelity on a big screen, at least for the foreseeable future, we're sticking with progressive download.
Yeah, I think I don't think there's a clear answer yet. I certainly don't think there's a satisfying answer. Internet video is still something that old broadcast guys, don't think counts as video. And I personally find that adaptive streaming can be somewhat distracting. I don't know if that's because I look at too much video, but I see the resolution shifts, and I might actually prefer to stay at a lower one for the duration of a session that would work. But no, I mean fundamentally, both the customers and the technology are still reactive, and the situation's changing fast. I don't see a clear solution at all, and I don't see anything like an ATM sort of reserve capacity end to end coming anytime soon. Even as we talk about CDN interoperability, no one's talking about reserve capacity or particularly localized reserve capacity at that level. So I think it's going to be best effort and a bit of a free for all for a while longer.
So, if you look at the evolution of video in the past 5 years or so, last 5 years has largely been about just getting video to the screens. That in itself was a challenge. YouTube started the trend, and doing it progressive download was the one way, the least common denominator. It worked every way, but still you had to deal with codec changes, resolution changes, all that. Those were the challenges. But going forward, if most of those have been resolved, most screens are at least on about 720p resolution. Even the iPhone is there, and most devices can decode video at entry-level HD, 720p. So those codec resolution level issues are getting resolved. What remains is the containerization, right, and the transport mechanism. And there's a lot of options, right, in terms of delivery right now. There is the HTTP Live from Apple. There is Microsoft Smooth Streaming, and Adobe has its own. But in that is probably going to be largely resolved in the next 12 to 24 months, partly because HTTP live streaming for all its Apple's one-sided invention is kind of becoming a de facto standard. If you look at Android 3.0, it supports HTTP Live now. And if you look at Microsoft's IIS server, now it supports that. And Real, any of the guys who are selling streaming servers, they support HTTP Live now. So it's becoming kind of a de facto standard in some sense. And on the other extreme, you have MPEG, which is working on an adaptive streaming standard, which is in the late stages of standardization. So by end of this year, early next year, at least the spec will be ready. It remains to be seen if the industry bothers or it becomes another of MPEG standards that doesn't get used. But we're getting there. So in the next 12 to 24 months, either an industry open standard like an MPEG adaptive streaming standard or HTTP Live type de facto standard should help consolidate this fragmentation.
Question?
Do you see a role for multicast, IP multicast in streaming live events?
I really, really wish yes. Right. I mean, Kevin Towse at Adobe is tired of hearing me bang on it, but now they've got it for the enterprise side distribution, although not last mile. There are a tremendous number of things that would work better if we could get it deployed. That said, multicast remains very much a checkbox feature, mostly from the router manufacturers, from software support, et cetera. No one has ever. It's the thing that always gets cut when people are short on time on their feature set. So, and at the same time, the network architects are very afraid of it because it's not quite the same as a reserve capacity model, but despite the fact that it promises to make things better, I think people are afraid of their routers being too smart. And the fact that their router is carrying some additional table frightens them a little bit in terms of performance of their core routers. I'm not exactly sure where the fear comes from, but I don't see any momentum to make multicast across networks yet, as much as it would make live streaming work a lot easier and a lot more scalably.
Yeah, I think the issue is not out of being afraid. It's multicast sounds easy to implement, but all you need is one little element in a network to make it not go. You can deal with in some of network or our size. You're talking about millions and millions of elements that have to all be updated, and you just miss one in that mix, which sounds weird. How do you miss one? It's millions. Yeah. Then it doesn't work. And then the tools to manage multicast traffic are still very, very immature. But we have absolutely stated that on our LTE network, our 4G network, we were looking at, we don't use the term multicast, but a broadcast type of methodology off of a reserved capacity. But even there, it's more to get up and get started, and it's not a huge portion of the spectrum, just again, because of the complexity of plumbing from point A to all of those point Bs and making sure every last thing works, including TCP/IP stacks on devices. You come across them, they don't even know what the heck this kind of traffic is to deal with. So it's just a huge amount of network engineering, wrench turning to make it go. I don't think it comes anytime in the near term.
Yes, just a bit more colour on the complexity of content processing you talked about in the multi-device environment. What are the panel's thoughts on the pros and cons of performing those functions at the centre as part of the media workflow environment versus those functions moving kind of deeper into the cloud as part of the delivery environment?
Yeah, I think it's similar to live video in the sense of it's primarily it's a reserved capacity issue and a control over content issue. So, for example, if you buy the transcoding gear yourself, you always know that it's available. Versus depending on sort of the burstability of cloud infrastructure to do it for you. Likewise, in terms of control of the assets, it depends on whether you're comfortable having these particular assets out in someone else's infrastructure. So we often see that the mezzanine asset policies around mezzanine assets are much more skewed towards protection than the final delivery forms. But we think that in general we'll see more and more of this stuff moving out as appetite for shifting over the gear every 3 years or every 18 months decreases.
I take an outrageously simplistic view to this question. That is, storage is dramatically cheaper than processing, especially real-time processing. The other disadvantage you get in real-time transcoding is a hit in fidelity and quality. You can do a much better job with multiple passes and batching and human eyes on it and try again and setting filters as opposed to on the way out. So it's just unit for unit, the storage, and I don't see any trend that says that that's necessarily going to change. The storage is just much cheaper. Just put 50 copies of it is way cheaper than trying to keep up with 1 million, 10 million, 20 million sessions of real-time transcoding.
If you look at, Digital Rapids has launched a series of product expansions where they're really blurring the line between doing it on-site and off-site, and through the ability to do programmatically configured workflow, where you also can have the best of both and have some gear on site, but also extend video processing challenges out into other people's infrastructure as you need to.
optimal point of where you want and therefore the benefit you could get from the CDN?
It does very much. Yeah, basically as the working set size, as the hot working set decreases, it becomes less effective to put caches out there. They simply become more pass-through devices that you're paying to keep the drive spinning in. So yeah, very much it's all about critical mass and the extent to which, I mean, the ideal situation is always 1 million people in the same place watching the same thing, but it's not settling yet as to what a particular event is and what its popularity is, and we find that stuff to be fairly unpredictable still. But yes, it absolutely figures into the calculation of effectiveness and how far downstream the caches can go.
I mean, bottom line is, given that the numbers changing from fixed, as you compare fixed to mobile, how attractive is the mobile CDN opportunity? I'm seeing kind of a big upside and a big downside now. What does it come out to in the market?
You have to do it.
I mean, if you look at the 3G network today, for a carrier with, say, 100 million subscribers and, say, 10 regional data centers, each data center is supporting 10 million subscribers. So then you do have the critical mass that Josh was talking about, right? But as you go into 4G, this is going to get broken further down, not into 10 regional data centers, but maybe 100 metro data centers. And then you're going down in scale from 10 million subscribers on one cache to maybe 1 million on each cache. And do you have the critical mass? That's the question you're getting to. At 1 million subs, it's highly likely popular content, say, from the homepage of YouTube will still be worth caching. But if you go further down to, say, a local, the cell tower or, a handful of cell towers, that which support maybe tens of thousands of subscribers, is there critical mass there to do caching at that level? That's a question to be answered.
And this cacheability is extremely susceptible to very minor factors like site design and time of day. For instance, we see customers that are effectively in all other ways the same in terms of traffic volumes, but one site has a player that shows one video on the front and you have to scroll to see any other videos, will have a much taller head than a site that puts up thumbnails for 40 videos in a grid. And just that is enough to make a dramatic difference in the cacheability of the content. So it's very difficult to predict, unfortunately.
But I think one of the cool things, though, is mobile and a lot of the fixed viewing are extremely complementary. When you're seeing big spikes on fixed, you're generally seeing a downtick on mobile and vice versa. And probably the biggest hits on mobile are very event-driven. Everybody gets together to see some sports event or some other type of music festival. So, but in general, you don't see the spike at the same time on your fixed delivery. So if you can get those fixed and wireless networks working together on the same CDN, then you actually end up with some pretty great efficiencies as opposed to building two separate infrastructures where one sits idle while the other's working hard.
So just in the interest of time, I'm going to wrap up with a final question. Based on what you just said, and also based on what we were talking about earlier, how the 4G architecture could mimic a traditional CDN architecture in terms of caching up the metro rings, I'm curious for your response to the question that as you see the mobile CDN requirements evolving with 4G and slightly bigger tablet type of devices, and then the traditional CDN evolving because they're also going across different devices, maybe now a PC and a TV screen or other types of things. Are we really talking about just one CDN, or are we talking about truly unique qualities for a mobile CDN?
I hope for the P&L it ends up being one CDN. Yeah, I think ultimately we'll get to, especially when you look at 4G in some places, even in jitter, is not that far off of some of the DSL connections. So all indications are we should be able to get this piled into one CDN, but it's going to be about the cache locations is probably the biggest conversation, and not trying to push them all the way down to the tower in every instance. And so I think it's just going to be the balancing act of where you put your elements.
Any other thoughts?
On wireless, the cost per bit per hertz is up to 5-6 times of fixed networks today. and it will continue to be a premium channel. So there might always be opportunities for doing mobile-specific extensions to traditional fixed network CDNs. But it's going to be a challenge on identifying the opportunities because it's always fluctuating as the technologies evolve, both fixed and wireless side.
Thanks very much.